Hi. So today we will be studying about dynamic subagent creation and role assignment, and we will also be going through agent registry and metadata database. So AI agents are autonomous systems designed to perceive their environment, process the information, and take actions to achieve specific goals. So they can either be rule-based or can be driven by various machine learning models, or they can often create and interact with different agents as well. So in in an agentic architecture, AI agents can, dynamically create, configure, and deploy other agents based on the task requirements. So this is basically done using a self-replicating, task delegating, or a hierarchical-based system. So to scale a super AI agents infrastructure, we need two different modules. The first one is dynamic sub-agent creation and role assignment, and the second thing is agent registry and the metadata database. So now coming to the key requirements, the key features and requirements of an AI agentic universe. So the first thing that is dynamic sub-agent creation and role assignment module. So in this, basically, a problem statement or query is given from an external agent, probably a super parent agent. The output is a list of newly created subagents, if needed, with their roles, their descriptions, and their different task prompts. So basically, a parent agent is there and a problem statement is given. Now now different roles are assigned, role descriptions and task prompts are assigned to each subagent. Now we will be using JSON output from LLMs to ensure structured and aligned agent creation. Then we will consult the agent registry, which is we will be using Chroma DB for the agent metadata storage and Neo4j for graph-based agent-agent relationship management. So to consult the agent registry and metadata database to avoid duplicate agents. Now we will be using the following fields for agent creation. So every agent should have an agent ID, a role, a certain role which has been assigned to an agent and it is supposed to perform that. A role description, a task prompt, a parent agent ID, which is the ID of the parent agent which has created a subsequent agent, various dependencies, and obviously some metadata like timestamp or the LLM used to create that agent. Now, the second thing is agent registry and metadata database module. So basically, we maintain a database for all the agents in the ecosystem. We use Chroma DB to store metadata, agent metadata, and we use Neo4j to store agent-agent relationships, parent-child dependencies and all. Now we check for existing agents. If there's a problem that is given, if there is an existing agent that can solve that problem, then we will be using that agent to solve the problem. Otherwise, we will create a new agent. So these newly created agents will be registered with their metadata in the Chroma DB and the relationships in the Neo4j. So this is the designed workflow. So basically, a problem statement input is given. So an external agent sends a problem statement or query to the dynamic subagent creation and role assignment module. Now, the second thing that happens is we consult the agent registry. Now, the model consults the agent registry to check if existing agents are there or not. Now comes the agent creation. So if there are no existing agents found that can handle the task, the module will dynamically create new subagents, assign roles, descriptions, and task prompts to each subagent, and this uses JSON output from the LLMs to structure agent creation. Third thing is the module may require multiple turns to create agents, considering the context of existing agents. Now, if we need new agents to be created, so once all the new agents are created, the module sends the final list of the metadata and the relationship to the agent registry. And then the list of agents is stored in meta. So yeah, agent registry ensures that the agent dependencies, which is like the parent-child relationships, are correctly stored in Neo4j, and all the metadata of the newly created agents is stored in Chroma DB. So I will be showing a demo as well. So basically, this is the code base that I have designed. So the LLM that we are using for creating the agent is Llama 3.1. You can use Llama 3.2 as well. And I'm using Fast API to give the input. So this code base basically has a main.py file. Then we have a Chroma DB database, Neo4j database, and also agent creation file. Uh, okay, so I will just give a demo. Yeah, so the fast API is started. Now I have created a validation file since I was trying this earlier. So I will give parent A as the first parent ID. So this is the master agent that is being created. Parent A is the first parent ID. And I'm giving this problem statement as the first problem statement. So ideally, this is the first agent that is being created in the entire agentic AI universe with a parent ID of parent A and a certain problem statement. Now, this is the first time we are giving this problem statement. So this means there's no existing agent which can solve this problem. So ideally, it should create a new agent. So let's see what happens. We can check the logs over here. The log says no sufficiently similar agent found, which means a new agent will be created. Yeah, it usually takes a bit time to create a new agent for the first time. Yeah, here. So a new agent has been created and mapped, and we can check for the same in Neo4j. Yeah, so this is a query which we use in Neo4j to get the graphs. Yeah, so this is a parent A, that is the dummy agent that was there with the agent ID as parent A, and this depends on a newly created agent which can solve the problem. The problem statement is create a data analysis report, basically the problem statement that we gave. And the role assigned to this agent is data analyst. Now we will check for some new ones. If we give a similar problem, so if I give a new problem statement, so this is a new problem statement and I will change the parent ID. So now ideally what should happen? So since this is a new problem statement, but it is very similar to the previous one. So the previous created agent should be able to solve this problem. So ideally the new parent should be mapped to the already previously created agent. Now coming to how we are deciding if new agent is needed or not. So we are using the similarity search, which is there in vector databases since we are using Chroma DB. So we are using the similarity search and we have defined a certain threshold. Let's see what happens now. Yeah, so this says existing agent is found and mapped. So no new agent was created. The already existing agent could solve this problem. Let's check this in Neo4j. Yeah, so the new agent is mapped to the already existing agent. I will show one more example. So, okay, let's give one more new problem statement. So ideally there should be a new agent created for this problem statement. So the parent agent for this problem statement would be parent C. If you check the logs, it says that it is creating a new agent since no sufficiently similar agent found. Yeah, so it has created a new agent. We can check the same in Neo4j. Yeah, so for this parent, a new agent has been created. So that was all from my side, and this was the demo of about how agents, AI agents can be used to create new agents. Thank you.